So that's a description of graphics associated with the three basic modes that we deal with. And if we look at other modes, for example, let's look at this mixed mode of SIMD volume control with pressure support. All we're doing is looking at a mode that has a combination of a constant flow and a constant pressure. So in this case, if I set a pressure support level of 15 and I'm in volume control, so I'm delivering this breath in that period of time is my mandatory breath, so my flow rate just for these breaths is going to be 30 liters per minute, but what will the flow rate be for this breath? We don't know, because this is a pure spontaneous breath when this occurs. So if I turn this rate down a little bit, I'm still delivering that volume in that period of time. So here, we see there's our constant flow again, back to 30 liters per minute for 1 second, delivering our 500 cc's. But in between those breaths, there's my constant pressure and my decelerating flow. But in this case, my constant pressure in pressure support is set at a certain value. As we saw when I set it up, it was set at 15. But flow is variable because, and I time is variable because in pressure support I can take a long breath or short breath. But in a control breath, I'm restricted to whatever I time I have set. So using those mixed modes of IMB, it's just a matter of how what we're mixing it with. So here in SIMD pressure control, pressure support, you'll notice that the waveforms are the same between the mandatory breath and the support breath. And we can tell the difference because one, the support breath is less pressure, but if I set the pressure the same, now how do we tell the difference between the mandatory breath and the support breath? So there's a mandatory breath and a support breath. So how do we know the difference other than the purple line there? We know the difference because the support breaths may be less or more of an I time than the mandatory breath. So we know that these are support breaths and that's a mandatory breath. And there's a support breath because it's longer than that 1 second. And keep in mind that these hash marks are 1 second between these hash marks. So you can kind of get an idea of how long the I time is. And in PRVC, what do you expect the waveforms to look like? SIMB PRVC? They'll be pretty much the same. There's your mandatory breath, and there's your support breath. So if you don't look at the time, you won't be able to tell which is which. So one other thing to talk about in terms of waveforms is the notion of auto peep. So to go back to pressure control, as we talked about earlier, our patient gets a breath here and then exhalation occurs here. And as I said earlier, when we exhale to some peak flow and then come back to baseline before we're delivered the next breath. So in this case, do we know whether we have any inadvertent peep? Well, we don't have any inadvertent peep because our expiratory flow comes back to baseline, 0, and then we deliver the next breath. So there is no air trapping or inadvertent peep in this scenario. If I increase the respiratory rate, do we have any inadvertent or auto peep now? Well, there we have inadvertent peep, and we can tell. That's why I said I'd always, if I could only have one waveform, it would be the flow waveform because I can tell so much more with it. So here, I don't have, my flow is not coming back to baseline. So whatever volume I would have gotten out in that little triangle there, between there and there, is the volume that I'm trapping in the lung, which more volume is creating a greater pressure. which would generate auto peak. Okay? So how much auto peak do I have? Okay, well, first of all, let me go back here. I suppose, back up just a little bit, if I knew that my scale was 150 liters per minute from here to here, I could guesstimate and draw kind of an imaginary line back from this point here, and say that my V dot EE, or the amount of flow that's still coming out, is, I don't know, 10 liters per minute. But why don't I let the ventilator do that for me? So if I plink the additional value key and I go to the next page, if anybody's ever looked at this and wondered what it is, it says V dot EE in liters per minute. So this is flow and expiratory. This is the amount of flow that's coming out of the lung immediately before the next breath is delivered. So what the ventilator is doing is actually measuring the flow right at this point, right where the red dot is. It's how much flow is still coming out, and at that point there's still 15 liters per minute of flow coming out. That being the case, I can say that I have inadvertent peak because this flow is still coming out, but I've delivered another breath. So if you ever see the flow not coming back to baseline, you know you have inadvertent peak. But the question will be, well, what is it? How much PEEP am I creating? Because PEEP is a function of pressure, right? Well, if we go to the next page, we have a value called total PEEP. To do a total PEEP measurement, we need to do an expiratory hold. And when we do an expiratory hold, we're going to measure the total amount of pressure that will be in the lung during exhalation. So when I do an expiratory hold, notice how it jumped up here from this is my set PEEP, and this is my total PEEP from here to here. So when I take my finger off the hold button, my total PEEP is 8 centimeters of pressure. My set PEEP is 5, so I have 3 centimeters of inadvertent PEEP in the system as a result of this air traffic. If I turn my rate down, allowing the patient more time for exhalation, what happened to my V dot EE, my flow and expiratory? What happened to this value? Well, it went to 0 because now the ventilator is measuring 0 flow immediately before the next breath. So then if I go to my next page and do a total PEEP measurement, which is once again an expiratory hold, when I do an expiratory hold, notice that there's no increase in the amount of pressure. When I let go, the amount of total PEEP that I have is 5, my set PEEP is 5, so consequently my inadvertent PEEP is 0. 5 minus 5 is 0. So talking about that, and we can also do, while I'm here, we can do a compliance measurement, which would mean I want to take a plateau pressure, and then I want to do a total PEEP measurement so the ventilator then can calculate what my static compliance is. So in order to do that, I'll do an inspiratory hold. So now the ventilator's doing, and we have a small leak in the circuit, because you see how it keeps dropping as I hold it? So that means that I have a small leak in the circuit. But if I do an inspiratory hold followed by an expiratory hold, the ventilator now will have enough information to calculate my static compliance, which is 23 cc's per centimeter of water pressure. Which means that for every centimeter of pressure that I deliver, I can generate 23 cc's of volume. So from there we can figure out how much pressure it would take to deliver a certain volume. So if I wanted to deliver 230 cc's tidal volume, I would simply set my pressure at 10 and I would be delivering 230 cc's because my compliance is 23. 23 times 10 is 230 cc's. So that's pretty much it on graphics, on a quick review of graphics.